Good afternoon, everybody. I'm going to present the outputs of the Project Open Machine Learning training data for visual tagging of construction-specific objects. I'm going to concentrate on the outputs, which is 2 data sets. If you want to learn more about the pipeline and how we generated the outputs and the statistical properties towards machine learning, you'll have to download the report and read that one. And on the bottom, please find my collaborators, David Griffiths, Fabio Panella, and Victor Melati. They're open data sets, which is important to us because we want to learn from basically the digital economy where open data sets, the sharing of IP, of experience, of code was really one of the key components of that drives innovation and drives growth in the end. And I think construction can learn a bit from that. They are actually data sets that will help you automatically derive semantic information from reality capture data and populate asset information models or project information model from there. There are 2 data sets. The first one is FireNet, which is basically a collection of images of fire safety equipment, fire extinguishers, emergency exit signs. The construction-specific aspect here is that they're actually linked to Uniclass, which makes them immediately useful for populating asset information models. They have 8 classes together, and for every class we strive to have at least 200 real examples of them, which should be enough at the moment to teach deep learning network architectures. Okay, so what do they provide label-wise? They provide labels for the image, so classification. They provide bounding boxes for the location of the object, for object detection, and they provide per pixel information for the semantic segmentation. So these are the 3 main tasks at the moment as visual deep learning: image classification, object detection, and semantic segmentation. We basically provide the labels for all 3 tasks. How did we derive the labels? Just quickly, those were crowdsourced labels. We paid people through Amazon Mechanical Turk to provide these labels to us. Something in between 1/3 and 2/3 of that information is trash, so we have to give the task out multiple times and sift it, and basically the effort is then in sifting out the true data from the false data. But most of the bulk of the work is done through crowdsourcing. Second data set is Synth City. This is a synthetic data set which simulates the scanner geometry of a LiDAR system that's mounted on a vehicle driving through an urban scenario. We have 9 classes per point, which gives the typical urban infrastructure, roads, facades, and the like. Here it's millions of points, so it's a rather big point cloud, and we provide semantic labels for every single point in that scene. The deep network architectures that are connected to that are more experimental at the moment, so I have to go into literature, and a lot of that is in the report. The accuracies are not at par at the moment with sort of the image deep learning. So this is just a view of the data set. What you actually should see is that there's seemingly holes or shadows in there. This is because we're really simulating a scanner that's mounted on a vehicle. So this is trying to be as realistic to a real scanning data set as possible. Why did we synthesize and not manually label a real data set? Well, simply in 3D, that's at the moment not feasible. The manual effort that would go into that would have basically exploded the budget of the project. So this is rendered in the Amazon cloud with about 100 nodes over a week. And these are the semantic labels, as I said: road, pavement, ground, facades, and etc. So both data sets are basically available since the end of the project. They've been downloaded already several hundred times. They're available via the UCL Research Data Repository. The future plans, of course, we're going to maintain and expand these data sets. We are looking for partners to develop applications on top of those data sets, and we're very willing to share our know-how, our tool chain, and so forth. If anybody wants to extend it, has suggestions for different classes, or wants to tackle a similar problem, email me, download the data sets. If you're too busy at the moment typing them down, there's QR codes on the poster. You can just directly link them. You won't be able to download them to your mobile phone. There's several gigabytes large. Thank you very much.